Did an ancient river cause the mass extinctions of the largest mammals of North America? In this series, we'll look at what happened and ask some of the big questions that are still debated today. Let's start about 13,000 years ago. The last ice age, or last glacial period, was ending. Temperatures were slowly rising. Forests began to retake the cold tundras of North America. Ice sheets and glaciers were retreating. Then, suddenly, the Ice Age returned with a vengeance. The cold weather was back, and it lasted another 1,000 years. This sudden cold period may have contributed to the extinction of the largest mammals of North America. These animals included saber-toothed cats, woolly mammoths, and giant ground sloths. But what could have caused this setback in the world's recovery from the Ice Age? The 2019 book End of the Megafauna explains, the Northern Hemisphere experienced notable warming beginning around 15,000 years before present. Then, 12,900 years ago, temperatures plummeted to levels as cold as those of the last glacial maximum in the Northern Hemisphere. Pollen evidence shows that this mother of all chills had a rapid, catastrophic effect on vegetation at higher latitudes, turning recovering landscapes into bleak tundra once again. This cold period is called the Younger Dryas. It is named after the plant Dryas octopetala, which thrives in cold, dry environments. Ancient layers of pollen from these little white flowers left evidence of a sudden cold period when the last glacial period had been ending. But why would temperatures suddenly drop like that? Recent investigations do support the idea that 12,900 years ago, immense amounts of glacial meltwater were suddenly released into the Atlantic and Arctic Ocean, possibly shutting down deep water circulation. Shutting down what? In the 2004 film The Day After Tomorrow, the scientist played by Dennis Quaid actually explains it pretty well. The Northern Hemisphere owes its temperate climate to the North Atlantic Current. Heat from the sun arrives at the equator and is carried north by the ocean. But global warming is melting the polar ice caps and disrupting this flow. Eventually, it will shut down. And when that occurs, there goes our warm climate. The books First Peoples in a New World and A History of Earth in 100 Groundbreaking Discoveries explains in more detail. The world's oceans, particularly the Atlantic, contain a grand system of watery conveyor belts that distribute and equilibrate global heat between the equator and the poles. This circulation operates very efficiently nowadays because of the large temperature difference between the equator and the poles, and because of the relative salinity of the North Atlantic, which is critical to the density-driven sinking that drives deep water formation. But if there was a large injection of fresh water into the northern gears of the conveyor, the surface water will fail to sink, and when that happens, thermohaline circulation slows to a halt or simply collapses. The Younger Dryas cold snap seems to have been triggered by huge volumes of fresh, cold meltwaters flowing from the melting North American ice sheet into the North Atlantic. The influx damped down normal ocean circulation patterns, most notably the warm Gulf Stream flowing across the Atlantic towards Europe, and produced cooler sea surface temperatures in the tropics. But what could have caused this huge flood of fresh water? The prime suspect is a long-gone lake in Canada. Great as the Great Lakes are, they are little more than kiddie pools compared to the now vanished glacial Lake Agassi. Over its 4,000-year lifespan, Lake Agassi rose and fell, but overall it was a downward trend as water made its way back to the sea. Early on, the water went south down the Mississippi River into the Gulf of Mexico. Later, it flowed east into the Lake Superior Basin and out into the North Atlantic. 9,500 cubic kilometers of very cold, very fresh water was flushed into the North Atlantic. If my geography is correct, I guess we can call this the St. Lawrence River. Either way, the effect on the North Atlantic was shutting down thermohaline circulation and plunging the Northern Hemisphere back into near-glacial conditions for the next 1,000 years. Temperatures dropped, glaciers advanced southwards, and forests turned back into cold tundras. Now that we know what probably caused the Younger Dryas cold period, we're back to the original question. Did an ancient river cause the extinction of the largest mammals of North America? The answer is no, not directly. Some researchers even think the meltwater came straight from the Arctic Ocean, not from a river. Either way, what about the effects of the climate change that followed? In part 2 of this series, we'll look closer at that. Thank you for watching. Please like this video, subscribe to this channel for new videos every week or two, and see the description below for a list of books and films featured in this video.